Srinivasan Balasubramanian, short for Srini, make it easy for you. I'm a distinguished member of technical staff. I report into the CTO office, mainly look into standards and IP-related items. So today I'm trying to focus on the network security and particularly its relationship with 5G LANs and how we interconnect everything together. So fundamentally, we are looking at it from a zero trust strategy perspective. Zero trust essentially means functions, resources of all types, applications, services, user identity, different hardware components, compute resources, and all of the virtual LANs and other things, which we put everything together. Essentially, it's considered to be a resource from a zero trust perspective. And zero trust fundamentally requires every item to be individually protected and managed in a very sufficiently scalable manner. 5G LAN, inherently, we have ground up, tried and built everything to allow for this zero trust to be, as a philosophy, managed and handled. It essentially ensures that the identity of the different devices and the functions in the network to be clearly identified and managed, authenticated through a very strong authentication methodology, encrypted over the air and on the different hops of the network. It also tries to do a level of control from an API perspective using the SAML, security assertion markup language, so that the access into the network and the system as a whole is managed in a very effective manner. So essentially a very strong device identification and management and authentication and operation functions which are there. Looking closer into mutual authentication, both the devices and the network need to authenticate each other. Essentially, it doesn't make it in such a way that only the network authenticates the device and the device authenticates only the network kind of thing. It's always a mutual authentication functionality. It is inherently leverages all of the functions which developed from a 3GPP perspective. We have further enhanced it from a 5G LAN to further integrate it with our VLANs and the ACL functions, so that the identity of the device that is getting authenticated is clearly and always known ahead of time, and the known types of functions which are actually put in together, and what type of functions and the network resources that it can occupy and utilize is very clearly defined at any given point in time. And it's fully in control of the enterprise IT. So the simple reason being that defining something very complex can be useful, but unless the ease of deployment is there, it doesn't make it very practical. So essentially, we have enhanced the 5G LAN solution to allow for a very practical way of managing identities and deploying the systems and managing this network security in a very clean manner, in a very easy way to deploy and manage that. All of this is end-to-end encryption supported. It does both encryption, crypto, and it also does identity and integrity protection through the process. Over there is a very, very strong encryption. It uses the AES 256 methodology of doing that. It's even supports mechanisms by which your quantum compute-based methodology of hacking into the system can be prevented, quantum resistance, and essentially it allows for a way to very tightly couple the data traffic of a given UE or a different identity of a user hopping through the different hops in the network, so that it is fully integrated with the enterprise network components, going through the core network, the radio networks, and the enterprise network, so that the devices traffic is fully protected and it's not exposed at any given particular point in time. Even the hardware identities of the devices can be authenticated and verified. There are mechanisms by which we can even support the identities locking to specific devices using SIM locks, which is a little harder to manage, but there are simpler ways that we do management of hardware, and we know which devices are connected, and we clearly know how to manage the end-to-end operations of the different devices out there. So from an architectural perspective, you're looking at it from an end-user device perspective. The devices can be bots. It could be a handheld device. It could be headless devices, which are cameras and video cameras and other laptops kind of devices, which can be regular kind of operations which are there. It could be IoT and industrial IoT type of devices. All of these devices are connecting to a cellular RAN, which is 4G and 5G kind of RAN functionality, which is integrated with the Celona edge and managed with a Celona orchestrator functionality, all of which regulated, as you can see here, through hop-to-hop security and ensuring at no point in time is the data of an individual user or any function or any aspect of the enterprises being infringed upon at any given point in time. So what you're looking at is an AES security happening on the radio interface, which is a very strong security algorithm, which is there. This is the most sophisticated form which is out there right now. Between the Celona RAN and the edge, we use IPsec tunnel methodology, where all the functions and the interconnects between the different functions on the RAN node and the different nodes which are deployed on the campus are all IPsec protected. You also have a TLS tunnel from an orchestration functionality. Note that all of these edge functions and orchestration function can be deployed on-prem, or it could be outside of the premises on a public metro or a DMZ type of a cloud. From a radio perspective, all of the credentials are managed through a 3GPP defined, well-known methodology using the SIM credential distribution methodology. It doesn't have the enterprise IT having to do anything at this point in time, in the sense that enterprise IT has to just point to a user group and a type of credential which is managed through a global platform which is used by any of the regular macro networks in a very, very scalable manner, able to push the information of the credentials to the individual devices distributed through the Celona 5G LAN to the individual enterprises. We are able to very efficiently manage that in such a way that we can even allocate 50 credentials to a specific campus. And we don't have to have millions of devices the way the regular MNOs manages the different functionality. We are able to very efficiently allocate the credentials into the individual campuses and have the enterprise IT push the credentials to the individual devices. So all of this comes with the fact that there's got to be some facilities that we deal with. In the sense that having done all of this 5G LAN functionality, secured it, ensured that it's able to function very carefully on the whole network there. What do we actually at the end result achieve in all of this there? We fundamentally are able to do segregation and segmentation of traffic. Use the fundamental technology that we have developed, which is a patented microslicing technology. The microslicing technology relies on the enterprise IT identifying user groups and identifying the types of usage, the functional service and the access which a particular individual groups are allowed. And you connect the individual functions and you identify a specific devices to be plugged into the enterprise network into a specific VLAN, together with identifying the types of functional access. It could be specific services being offered within the enterprise. It could be exposure out of the enterprise going into the public internet. We can very selectively enable individual devices to manage and have the enterprise IT segment the traffic and manage the functionality. Apart from the segmentation of the traffic, it fundamentally has a mechanism by which we can say that the types of quality of service, something like voice or a video camera or a bot type of operation, which is happening in a kind of an enterprise environment, we are able to give very explicit parameterization of QoS management. And it is managed very tightly coupled with the enterprise VLAN, and it is managed with the 5GC core or packet core functionality connecting to the RAM and the scheduler functions, very effectively managing the scheduling both on the uplink and the downlink, so that the device get the quality of service both on the uplink and the downlink in a very, very efficient manner. And we manage the admission control and the priority of the different services, relative priority, which can be managed and specified by the enterprise IT. And we manage the behaviors of those functionality, meeting the SLAs with the scheduling functionalities that we implement. All of this is implemented in a very extensible architecture. We're looking at native microslices. It can run pretty much anywhere. But that could be bare metal provided by the enterprise campus. They identify the compute resource. We can provide or recommend specific compute resources as needed, but we can also allow it for it to run in a public cloud. It could run in any platform because the whole solution space is actually built as a microservices kind of architecture. And everything has extensible APIs for integration and functional management. So here's a view for you to see about Celona's intuitive dashboards, and did refer to something called the user group management. So primarily, the enterprise is managing the networks by identifying users in a system. And types of users in the system and what type of access, what type of functions they're allowed to do. And what this allows us to, was the enterprise IT to do is very easily specify which user groups are managed through what type of portals and what type of functionality. All of this is done through a single pane of glass. There's absolutely no knowledge of the wireless system, of the underlying complexities involved in the 4G, 5G network, which is involved in making this happen. It just managed in a very seamless manner of tying the credentials. And even the enterprise IT doesn't need to directly manage the credential because they are handled through the Celona provided platform for SIM credential distribution to the individual devices. All the enterprise IT has to do is type of device and the type of credential that needs to be pushed to the particular device. So this just gives you an illustrative, a quick view into the fact that how easy it is to actually provision the users, provision the types of applications and the device groups and functionality, and tie the two together to say that, hey, what applications can be accessed by what device groups, and managing the individual network components and the functional operation of the different devices which are involved in the type of security that can be enabled for the individual devices, including the hops within the network, apart from the over-the-air security which is involved. So all of this comes with data privacy, and Celona is able to provide a very strong data privacy across the board there. The data path control for privacy and compliance itself is managed. 100% of the data is managed and is retained within the enterprise. There's nothing that we expose outside of the enterprise. We do collect metrics enough to make the operational functionality happen. We don't collect individual user type of traffic information or anything like that to expose that. That's a Celona's privacy promise, where we never access the data payloads and do not sell, share, or monetize any client or meta kind of a data which is involved there. This is from a private network operation where we allow the enterprise IT to completely manage, control their data, log whatever they need, account for the metrics, and look at their own SLAs and try to manage their own networks. We help through the process of managed services to manage the individual networks, but all the information on the data privacy aspects of it remain within the enterprise campus itself. Apart from the private network, we also support neutral host networks. Neutral host networks being macro network operators, camping and entering the enterprise campus networks, and they're able to connect to their core network, but using the radio technology of what is deployed in the enterprise campus. What is happening here is essentially we make sure the traffic going through the neutral host, by that just the RAN or radio access network boxes, which are the access point E node B, G node Bs, are routed directly into the MNO core without actually touching the enterprise core, which implies our enterprise traffic is segregated right at the access point in a secure manner, sent directly to the MNO core networks which are there, which actually protects the MNO traffic in a very, very reliable manner, because there's no visibility within the enterprise network itself to hack into the neutral host traffic, which is happening. I did mention about the fact that the services can run anywhere. This is an illustrative view of that. It's essentially trying to point to the fact that, hey, the devices are connected through a microslice, because we identify what microslice. It could be a default internet type of traffic. It could be a voice traffic. It could be video traffic. It could be bot type of traffic, all of which is identified as a microslice. And the functional aspect of the microslices are realized through the microservices which are deployed functionally on the different cloud platforms. And these microservices, like I explained before, can run on the enterprise core, on the on-prem, on the edge itself. It could be on a metro network. It could be on a public cloud, or it could be on a DMZ, which is across a large enterprise where they have a DMZ protecting, which is allowed for the whole enterprise to be managed in a seamless manner. And we do effective load balancing and security management across the different hops to make sure that at no point in time is the data exposed across these transitions. There are times when we take a functional aspect of it and load balance, and if the capacity of the enterprise don't meet the needs, it actually moves that to a public cloud or to a metro cloud to better manage the capacity needs of an enterprise, which could be transient, yet saving the costs for the given enterprise to deal with additional compute needs, which are temporary in nature. At no point in time is any of the data exposed, and every hop is protected through a certificate authority. We manage everything in a hop-to-hop manner. At no point it's getting exposed all the way into the VLAN, and we follow the enterprise IT's security procedures, plugging into the VLAN and the enterprise IT, at no point in time defining what the enterprise policies are there from a security perspective. We do accommodate in any one of these methodologies, very stringent regulatory bodies can actually, on functions and organizations are able to easily manage the security functionality through the process without any exposure. And it's actually been shown to they have such very strong, stringent security procedures. So with that, I think I just want to conclude that discussion, and I just want to quickly say that please look at our demo and the different demos and look at the go into the celona.io/journey. You can find a lot of information through our websites, and you can actually look through a free trial or information through this link out there. I request you to follow the link to get more information and appreciate more of what it'll give you a better appreciation of what we are trying to show in terms of microslicing and security procedures and management of the devices and otherwise. Additionally, also please join our frequency forums and community, and do participate very actively in these communities.
You talked about user groups and device groups. Can you talk about how they're different and how they relate back to the policies that you're applying?
Devices are something like if I end up buying a bunch of iPhones or a bunch of Samsung devices, there are device types which are there, which are managing. The same iPhone can be used for multiple, functional, one used by, let's assume, a campus setup, like a university campus. Professors versus the employees versus the students are getting a different type of behaviors. There could be essentially CYOD device, which is choose your own device coming in, where they have a certain type of a user group which belongs to that, as opposed to BYOD, where you bring your own device into the functionality to manage that. So the devices are types of devices which are applicable on a campus, user groups being different devices being applied to different functional needs or functional allowance of what they are allowed to do on a particular campus.
So a device, a user could have multiple devices and could have multiple profiles and multiple different security policies applied and routing policies.
Sure. I think if you're referring it to that manner, yes, it is possible for that to happen. We typically tend to look at it from a single user using a single device type associated with a certain functionality onto the platform into our 5G LAN. But certainly a single user can have multiple devices.
Could you talk a little bit about your patent and what is special about the patent? Because you've talked about what it does, but I'm having trouble distinguishing between what's unique here versus normal routing on a network.
So essentially, there are different facets to the patentable concepts which are involved. If you look at it from a WLAN perspective, they have directory services and ACLs and management functionality. We need to take a functionality which is actually used by the macro networks handling millions of devices and plug that into an enterprise so that a few hundred devices can be managed at a given point in time. So fundamentally, what you're looking at is there is a difference in terms of the nature and the size of the the size of the number of the devices that you're managing. Apart from that, what we are fundamentally saying is the user groups and the device groups and the way the credentials are distributed to the devices and how they are plugged into the VLAN and how we solve some of that problem as a micro slice. You would have heard of what is called as a network slice from a 5G perspective. Network slices are much broader concept. It requires configuration onto the device, and the device has to access the network with a certain network slice request functionality, and it has to be tied into the core network, and there's an awful lot of management from the Android layers, the iOS layers to plug all of these pieces together. We do that in a very seamless manner where we are able to actually, without the user knowing, I mean, if you look at something very simple like an access point name, which is APN, every device has an access point name which needs to be configured on the device. we don't need that. We just have a single access point name, which are distributed across a plane, uniform across all devices. And we are able to distinguish in the network IT managed, where we are able to segregate the functionality across different devices based on the user group, device groups, like I mentioned, and the functional specific access that they need into the individual, resources within the enterprise campus, achieving a zero trust policy there. So everything is driven from the network and managed as a single pane to a single pane of glass to deal with the problem. So that's where the fundamental novelty happens. There are some deeper level functionality which is there, where we adapt the nature of the microslice, make it broader in the sense that we know what the external happenings are. We are able to adapt the performance of the network slice, adapting to different users, different time frames, and different days of the week, and we are able to actually manage some AI functionality and then combine that with a broader application of meeting the required SLAs in the process there. Yes, that's where the fundamentals of the IP lies.
And I mean, Ariel, there are multiple things here going on, of course, right? And there are multiple patterns on all of these things. But essentially, I mean, 3GPP has a framework, a standardized framework for generating different QoS IP flows with the QoS scheduler, right? And then it has a framework for SIM management and so forth. And then you go to the enterprise world in a IT workflow, there are VLANs, there are identity policy management frameworks, device groups. How do you bring those things together, right? So a lot of the innovation lies when we bring the two worlds together and make it in a, implement everything in a simple, scalable manner, so that through the single pane of glass, with click of a button, you can create device groups, as create some microslices for those devices and so forth.
Yeah, thank you very much. It makes a lot of sense, because you're using a lot of enterprise terminology, and you're kind of like bringing the cellular technology into the enterprise world. So I do understand what you're saying. This is fantastic. Thank you.